material wise. I'm just going to explain to you guys this project. For those of you that are a little behind on work, make sure that you're working through 7.1, 7.2, 7.3. Do the quiz, and 7.4. That should all be done before you start your project, honestly. I wouldn't try to start the project without going through those lessons if have been virtual. I think most of you here, though, have been here almost every day. So you should be all caught up. So then the rest of this week, all you have left is to do this project. It's in the Unit 7 folder at the very bottom, Regression Analysis Project. Make sure you read the directions, but I'm going to go over that with you right now. Okay. So this is what the project will do. It's going to pop up should I call this Google Slides. You're going to do your entire project in the Google Slides. And on the second slide is where the directions are at. Please, even though I'm going over this right now, please read it on your own before you start. Follow the directions. Okay. You guys are going to be looking at some data sets that I've given you, and you're going to pick your own data points, and you're going to create scatter plots and regression models. So you're going to create a linear regression, an exponential regression, and a logistic regression, the three different ones that we've learned so far. Okay. This is not a partner project. Everybody's doing it on their own. You guys will all turn in your own set. So please turn in, make sure you're picking your own data points, and you'll see what I'm talking about. There's thousands to choose from. Okay. Literally thousands. The project will be graded from this slides presentation, so please put all your work on here. There might be some cases where you might want to just draw it or write it out, and that's fine, but you need to take a picture of it, make it look nice, and put it into the slides. I'll have one spot to look at it. So here's what you can do in part one. Part one is pretty simple. You're going to go through these data sets. You're going to pick a topic, one of these three different topics, and you're going to choose two different variables to compare and see if there's some type of correlation between those two variables. Data set one is this right here. I have a spreadsheet that you guys will open up. It has got a list of over 20,000 different recipes. Some of these don't have the numbers in them, so obviously don't use the ones that are there that are going that are missing. But over 20,000 recipes in here to choose from. If you just keep scrolling through, there's so many of them. It tells you how many calories they have, how many proteins they have, how much fat, and how much sodium in each of these recipes. So this is a good spreadsheet right here with a lot of data in it. The second data set has over 100 different countries and a lot of different data on those countries. For example, it has death rates, birth rates, infant mortality rates, the GDP for those countries, the gross domestic product. You can pick two of these variables to compare in the different countries to see if there's some type of correlation between that. Is there a correlation between how much their GDP is and then how many people die or so on? On the last data set is I have about 100 different mammals that and how big their brains are compared to their bodies and how long it takes for them to be pregnant, the females, I should say, the gestation period, and how big their litters are. You know, a lot of these mammals only deliver one at a time, and you can see those there, but some of them deliver more than one baby at a time on average. These are all averages right here. So what you guys are going to do is you're just going to you're going to pick a set. And on the next slide, you're going to tell me what your topic is. Which one did you pick? Did you pick recipes? Did you pick world population? Or did you pick mammals? And then you're going to try to, once you pick a topic, you're going to try to determine if there's a correlation between two different variables. For example, at the bottom of there, I wrote an example there. I'm going to go back. If your topic is recipes, you could try to see if there's a correlation between calories and sodium. And then you're going to end up picking different combinations of those variables or 24 different recipes and compare the calories to the sodium and see what the scatter plot looks like. That's what you're going to basically do on this project. So on what you're going to pick those topics, and here's another example for you. This is what something might look like, and you're going to put those 24 different data points here. Let's say you picked recipes, so you would write recipes right here. You would pick calories in one of them, sodium in the other, and pick 24 different recipes. Okay. If you pick a recipe, abbreviate it. You don't really need to write the whole thing in there. Just abbreviate it or whatever. Tell me what it is. Tell me what the calories are. Tell me what the sodium is. for that particular recipe, and then do the next one. This part should not take you more than like 15, 20 minutes. Don't spend forever trying to pick different variables. Figure out what you want to do. If you want to do countries, pick 24 different countries. If you want to do mammals, pick 24 different mammals. If you want to do a recipe, pick 24 different recipes. But mix it up, guys. You cannot have the same answer as somebody else or the same answers as somebody else. Spread it out, mix it up. There is literally over 20,000 different recipes. There's over 100 countries, and there's over almost 100 mammals. There is no way for you to have the same exact answer as somebody else. All right, mix it up. Once you have those, all those 24 different whatever it is that you're doing, open up the Desmos Calculator. We've been practicing this. If you're behind on your homeworks, do these homeworks before you do this. But you should already know how to do this. I've already created the Desmos Calculator for you. It just it has a blank table. Fill in the 24 numbers in your table. All the X's down here, all the Y's down here, and it'll give you your little scatter plot. You're going to make sure you zoom in on it, follow the directions there. Make sure you label both the X and the Y axis with the correct variable. Okay, so this time I'm adding one new thing in there. Once you click this little button on the Desmos Calculator, you can actually label the X axis and you can label the Y axis. Please, that's part of what will be graded. So make sure you're labeling that. All right. On the next screen, you're going to take a picture of it. There's directions here on how to take a screenshot. There's directions here on how to save it from Desmos. Desmos has a save option, or you can just draw it if you really want to, but it needs to be a really good drawn to scale scatter plot, and then you can take a picture and upload it onto this slide, and you're going to put your graph right there. So that's done with part 2. Again, that shouldn't take very long once you have your data. Part 3 is only one slide. You're going to write the 3 different equations. All equations must start with y equals. And once you have your data in there, it gives you the equations, but you just have to put it in these forms. Go back to those assignments or ask me for help if you need help, especially with the logistic one, because we haven't practiced writing those. I will help you write those if you need help on the logistic equation. Okay. For the linear one only, write the correlation coefficient. Remember, that is R value right here. For all the equations, you're going to write the answers to 2 decimal places, every variable to 2 decimal places, so every part of that. Once you have all 3, then you're almost done. Part 4 is you're going to analyze just the same things that we've been doing. Describe the correlation. Which one do you think is the best choice in the form? So how strong is it? What direction is it going? Which form is it in? Is it linear? Is it exponential? Or is it logistic? Tell me why you think it's the best one. Use the buttons to turn it on and off on the screen so you can see which one fits it best. Interpret the information that your data is displaying. Tell me what you're learning from the graph. We've done a bunch of that already as well. Does it display correlation, causation, or neither? We've talked a little bit about correlation and causation. If you want to refresh, click the link. It'll open up a little refresh page about what's the difference between correlation and causation. You can have a little reading material there for you. And then the last slide is you're going to make any type of prediction that you want. You're going to use the equation that you picked as the best one, either the linear, the exponential, or the logistic, and you're going to pick literally any random number that you want. You can read the example there. If you had these 2 variables and you wanted to predict the average gestation period of a mammal with a brain weight of this 125 grams, you would just plug in 125 for X and solve for Y. You would do the same thing. Make a prediction of any type. Tell me whether or not it's interpolation or extrapolation. And if you don't remember what those words are, look back into the notes and or Google it. Okay. That's it. This whole project is literally designed to be done in less than an hour, guys. So anybody have any questions? Let's see who are the last ones.